Hello, this video is on section 6.7, which is inverse relations and functions. And the learning target for this is to find the inverse of a relation or function. And the one definition in this that we need to talk about first before we get into it is an inverse. And when we're talking about the inverse of any sort of data points, a function, a relation, it's basically taking your domain and range and switching them, or your x and y values and switching them. So this could be for a set of points, it could be for a graph or an equation, any of those. You're just switching the domain and range values or the x and the y values. So for example, if we have a relation with the domain of 2, 4, 6, and 9 mapped out to the range of 1 and 2, the inverse would give us new domain and range points that are switched. So our domain is 1 and 2, and the range is 2, 4, 6, and 9. And the same mapping happens between the points where they're going left to right, but instead, since our domain and range are flipped, they're just going in a different direction. So 1 gets mapped to 2 and 4, and then 2 goes to 6 and number 9. So in some instances, you may be able to look at a relation right here where there's two x values converging onto a y value. Then its inverse now becomes a function because there is only one x value for every y value. Now it may happen the other way where you start out with a function, then its inverse is no longer a function, it is a relation. And you see those instances a bit more when you're looking in the mapping of the points like this, or in a specific graph where you're looking at plotted points. A few examples to go over. Finding the inverse of equations of graphs is probably going to be the biggest thing in this section. So say we have the equation y equals x squared minus 1. Basically the way you find the inverse is you take whatever's in your equation and you switch the x and the y. So instead of y equals x squared minus 1, it becomes x equals y squared minus 1. And in order for this to be a function, we can't leave it as an x equals form. We have to get it y by itself, just like it is in here. So in order to get y by itself algebraically, you add 1 to both sides to get x plus 1 equals y squared. And then to undo a square, you simply take the square root of both sides. Then we're left with plus or minus the square root of x plus 1 is equal to y. And this is our inverse function. So the very first thing you want to do is you switch your x and your y values. Keep everything else in your equation the exact same. That's solve for y using algebra, and that is the inverse function. Same thing with this one over here with a y equals 2x plus 8. Wherever you see a y, you replace it with x, and wherever you see an x, you replace it with y. Now that we have our inverse relation, we have to make it into a function by solving for y. Subtract 8 on both sides, getting y by itself, then doing it one more time, dividing by 2. We have 1/2 x minus 4 is equal to y. And this is my inverse function. Y by itself, and it is the inverse of that. If you want to plug each of these into a graphing calculator as the y equals 2x plus 8 and y equals 1/2 x minus 4, what you'll actually see is that they are reflections of each other along the y equals x line, or I guess line of reflection. So this dotted line is the line of reflection between each of the functions. So if we're looking at x squared minus 1, I can graph. Looks like this. Its inverse function, which I'm going to draw right now, is basically taking it and reflecting it along the y equals x axis. So instead of this point being 0, -1, I'm going to reflect it up to here where it's -1 and 0, switching my x and y values to plot the points. This is the inverse function of y equals x squared minus 1, flipping it over the y equals x axis. Now in some instances you may see, instead of a y equals function, you'll see f of x. So the first thing I like to do, just to kind of alleviate some confusion, instead of f of x, just write it as a y. So we have y equals the square root of x minus 2. Now you can look at switching your x and y's as an x equals the square root of y minus 2 to get the inverse. Now in order to get y by itself, we must first get rid of this square root, so I'm going to square both sides. That cancels out with the radical, so I have x squared equals y minus 2. And then the last step to get y by itself, I'm just going to add 2 to both sides. So I have x squared equals, or x squared plus 2, sorry, x squared plus 2 equals y. And this is the inverse function. Okay, so in some instances you may have to plot points. If you do have to plot a point, you take whatever the original point value is of your x and y, and then you just switch it. You switch your x and your y's to get your inverse, just like you do with an equation. So the points work exactly the same way as the domain and range mapping, and as they do the exact same way with the equation. Okay, thank you.